There we go. All right. So I'll watch my cursing. So I'll do a test here and see how well it goes. All right, so what we're going to pick up tonight, like I said, this stuff is, I think, relatively easy. The book isn't too specific, not too specific. It's not too difficult, I don't think. It's like, here's the equation, just plug it in, etc. It's the stuff in chapter 6. So 6, again, talks about simple interest, compound interest, annuities, and mortgages.
Something I deal with all the time.
Exactly. And to be fair, this is not like week 12 finance. This is literally like week 1, week 2 finance, people finance course. So it's pretty straightforward on what it should be. So, so the 4 things: interest, simple interest, compound interest, and then annuities and mortgages. Okay, so simple interest. Okay. Simple interest. Okay, so that's section 1, if I remember correctly, right?
Mm-hmm.
Okay?
Yep.
All right, so it starts off page 243. It says, starts with this equation right there. The natural log of t is equal to p RT, correct?
Yes.
Perfect. Okay. All right. And I was an idiot the last time I taught this, and I was like, oh, interest, INT. No, that's not that. Oh, yes, I did. I did the exact same thing I did last time. Is that the natural log of t? I'm an idiot. I did the exact same thing I did last time. That's funny. All right. So in this case, the simple interest is calculated by taking, in this case, the principal, P. So P is the principal. So how much did you start with? What's your initial deposit? Okay. R is your interest rate, right? And that should be as a decimal, if I remember correctly. So, so decimal. And then T is time. If I remember right, it says time in years, correct?
Yes.
Yep. Perfect. All right. So to get your, no kidding, straightforward, you'll take your principal, how much you deposited, multiply it by the interest rate times your time. It's down and dirty. It's not perfect. It assumes no compounding. It's just boom, boom, boom. There you go. Okay? It's not meant to be, it's supposed to give you an idea to get you in the ballpark. So the first one, it says, a construction company borrows $30,000 for 2 years at 5% simple interest. How much interest must the construction company pay for the use of the money? All right. So construction company does their initial principal for $30,000. Okay, 30,000. All right. The interest rate is at 5%. Simple interest. And for how long does it say?
2 years.
2 years, perfect. So by the way, if it's in months or days or however it is, you have to make sure you convert that over to years and use it appropriately. So if it's like for 8 months, you have to convert it to 8 over 12, so that'd be what, 0.75 of a year. All right, so all you do, use the equation, plug it in here in this case. So interest, now this is just the interest, is equal to PRT. So the principal in this case would be $30,000 times the interest rate, which again would be 0.05 because it's 5%. So that would be 0.05. And then times 2. Oops. All right, so where's my calculator? All right, so 30,000 times 0.05 times 2.
3,000.
Yep, I got 3,000. And again, that is just the interest. So if they ask the question, how much did they pay total? Or sorry, yeah, how much would they have to pay total? Okay, you you'd have to add it up, like the total amount of the loan. Is it loan? It is a loan, right? Borrows, yes. Okay, so it's a loan. So the total spent for the loan is equal to the principal. So that'd be 30,000 plus 3,000 gets us to
3,300.
33,000. Yep, A firm. Alright. So again, simple interest is pretty straightforward. Principal times an interest rate times the time.
Is that the interest that they use for car loans?
Yes, but that would be, that car loan interest actually is compounded.
Is it compounded?
It's compounded, yep.
Every day?
I believe so, most of them are, yes.
That's why you get a 10-day payout.
Yep.
Yes, that makes sense. Okay.
Yep.
Got it. What do they use simple interest for? Like,
That is a great question. I do not know who uses simple interest. Unless it's compounded once maybe, which no one does that
yeah,
in the life of a loan. No one does that.
a loan shark.
Yeah.
They use simple interest.
Yeah, that's probably true. That is a very, very good point. Example 4 says, find the simple interest, interest for principal of 5,400 that is borrowed at a 3% over 8 months. Okay? So the second one here says it was $3,000?
No.
No,
5,400.
Oh, 54, thank you. Okay, and what was the interest? Or sorry, what was the rate?
3%.
3%? And that is at 8 months.
Yes.
Okay. So before I start, I have to, I look at my time. That's 8 months, so how much of a year is that? Right, we just convert over to,
2/3.
yep,
Yes, it is.
oh, it is 2/3, you're right. Is it?
Yes.
2,
2/3.
yeah, you're right. Take 4 into that,
Am I
4 goes, yeah, you're right. Holy cow, we're right then. Okay, so then we know it's 2/3 of a year. Then we just go back and use the equation. P times R times T. 5,400 times 0.03 times 2/3.
108.
$108. Okay, so, yeah, make sure, not 10. Yep. Alright. Again, pretty straightforward on this. You can modify, oh, go ahead, I'm sorry, Kev.
No, I was just wondering. Oh, okay, that's what I was on.
Okay.
Ah, gotcha, okay.
Yeah.
Never mind.
So you can modify it, you can go back and forth, whatnot. So for example, if you want to find T, we've done this in the past, you can just swap other variables around and solve for it. It's pretty straightforward.
Did you multiply? Did you use your actual scientific calculator? Use actual?
Oh, yeah. So
Yeah.
just take 5,400
Yeah, times 0.03.
and then do this, take times 2 divided by 3.
Gotcha. Okay.
So remember with this, if you're going to multiply this by a fraction, those can be considered this over this.
Gotcha, okay.
It all still
Makes sense.
works the same.
That makes sense.
Alright. Pretty straightforward. Any questions on that? So if I give you, like, let's say I give you the total interest, you can back calculate, I think that's the next one. No, they didn't give you an example of that. But, yeah, you can do that if you like. The next one talks about what's called future value. Alright? Future value is kind of like this idea where I can estimate that, I can get a number of what the value of that currency is going to be with an interest rate in the future. Okay? So it kind of takes the first two things, the total principal, and adds in whatever the interest you're gonna raise. So for example, on page 244, it gives it to you an equation there. It says FV is equal to P times 1 plus RT. All right, where again, FV is your future value. P is your principal. R is your interest rate, annual rate. And that's simple again. And T is your time in years. Okay? So what it's done, so the future value of whatever that is, like, so i.e., when you pay off your loan, how much total money did you spend on the loan? That's what you're calculating. Okay? And that's why I went back to this to show you, okay, this is the interest, but then this is what we started with. So in the end, when you get done paying the loan, you're paying $33,000. This equation will do that for you. It takes this and just goes and does this all together. That's all it does. Okay? So, example 3 on 245 says, if a principal of $2,800 is invested over 5 years, this is 5 years, right?
Yeah.
Okay, 5 years at a 3.4% interest rate. What will be the future value? And again, this can be like a loan, it can be doing it the other way around, investment. At the end of the day, hey, what did I earn? So, Kev, to be honest, like you were saying, well, what do I use these equations for? This is for you to like sit at home and like rough guess. Like, hey, if I do this, what would I generally speaking be looking for? Not super accurate, but at least in the neighborhood. All right. Okay, so then we just plug and chug. In this case, FV equals 2,800 times 1 plus R, which is 3.4. So as a decimal, that would be 0.034. All right. Times 5. Or times 5, period. Okay. We go back in here, we get 2,800 times 1, oops, my button, 0.034 times 5 plus 1 is 1.17. So everything in the, so 0.034 times 5 should be 0.17. Add 1, you get 1.17. Is that what you get, Kim?
Well, like a dummy, I didn't do the parentheses first.
Oh, okay.
Yeah, 1.7.
Okay, and then when you multiply it by 2,800, you get 3276. So when you're done investing at the 5 years, you should get that. Pretty, like I said, pretty straightforward, down and dirty, nothing too mind-blowing. Alright, another great example is my husband and I just opened we went to Service Credit, we just wanted to have something that was kind of liquid, a liquid savings account, if you will, that we could make good, decent money on. It's okay, nothing too spectacular. So we deposited $3,000 into a Christmas fund, and apparently that's the best interest rate you can get as a Christmas fund.
Really?
Yeah, strangely enough. In 10 days we made $9 on it. So it's not, yeah, I know it's not too great, but it's like, oh wow, it's actually not too bad considering at the end of the month you should make $30 if I remember right. Does that sound right? And then so by the end of the year you should make $300 on it if I remember right. So you go full 12 months. Does that sound right? $9? No, 3, 10. Yeah, no, 10. Yeah, 10, 20, 30. Yeah, $30. Not right? No, it's $10 a month. No, I can't remember. See, even I'm confusing myself.
Well, it's better than a standard savings kind of.
No joke. Yes. Completely agree. Alright.
Who'd you open that up with?
Service Credit. Yeah. Okay, we'll do one more. Make it, we'll go to page 248. Page 248, example 11, number 12, or sorry, number 11. It says, find the simple interest rate for a principal of $325,000 that is borrowed at simple interest of 12.5% for a period of 150 days. Okay. Number 12 on page 248. Wants to know what is the interest, given the principal is $325,000. The interest rate is 12.5, and the time is how long?
150 days.
Okay. Okay. So, go back, it's just asking just for the interest, correct? For the simple interest, yep. Okay, so we use the INT, not the natural log of t. All right, don't do that. Okay, so interest is equal to principal times rate times time. Okay, so principal is 325,000 times the rate. In this case, it'll be 12.5%. Make that a decimal. Kev, if you make that a decimal, what's that become?
So 0.125, right? 0.0125.
0.125. Yeah, remember, just move it two over.
Twice, right? Yeah.
Yep. Just two. Okay, so then that's 0.125. And then we have 150 days. Okay, how many days are there in a year?
365.
Yep, 365. So if we divide that by 365 days, what does that equal?
0.4109.
0.0419.
109.
109, sorry. Is that right? Okay. Give me two more digits.
58.
58, perfect. We're messing with money, we want to make sure we're accurate, right? Okay. Kev's like, no, I'm just not good money. Throws out the window. So if you multiply all three of those together, 325,000 times 325,000 times 0.125 times 0.410958. I got 16,695.
Yeah.
Yes.
Perfect.
That's a lot of money.
That is a lot of money. Holy cow.
16,600.
Oh, 600? Oh yeah, thank you, 600. Thank you, thank you.
That's what you said.
I did, and I wrote something different. I just like to get kicked out.
Nuts.
Alright. Alright. Any questions? Kev, questions? You want to do another one, or what would you like to do? Okay, how about we do number 21? If the future value is 18,342, okay, so it says the future value, and this is number 21. Future value is 18,342, and the present value is equal to
18,000.
18,000. For a 3-month investment, what is R? All right. So for this, oh, and it does say it's a simple interest rate. So it does say simple. So it lets you know, simple interest, okay, two equations to look at. That one and this one. And it triggers, should trigger you. Present value, P, or however you want to look at it. Future value, present value, don't get a present value, or sorry, future value in that one, so it's this equation they're looking at. So then we just take FV is equal to PV, or P times 1 plus RT. We plug everything in here, we get 18,000 342. Okay. Equal to
18,000.
18,000, yep. Alright. Times 1
Plus 1/14,
plus,
or R.
R times, yeah, that should be 1/4, you're right. Okay, so we go back over here, Kev. If I'm going too fast, let me know, I'll slow down. 3 months here becomes 3/12, which is 1/4.
Mhm.
So we'll come over here, and this is, I'll change this to 1 plus 0.25 t.
Isn't it supposed to be R?
I thought it was R.
Oh, R, thank you.
You're
my
just
mo-
sharpshooter shut.
I know.
Jeez.
You know what's funny, is as I was writing that, I was like, oh, I'm gonna flip the order here. So as I'm thinking to myself, I'm flipping the order, I still wrote T. That's so funny. Okay. All right. So now we will, so how do we get R? How do we solve R? Okay, well first, what do we do, Kev?
Would you multiply the 18,000 times the 0.25? No, you gotta get those parentheses in there first. Yeah, I kind of put those in there.
Okay, no, that's fair. It's kind of going backwards now from what PennDOS taught us. We still want to get the R on one side and get the numbers over here. So first thing we want to do is take 18,000 and divide it off. Because we want to get rid of it off of this. So then we're left with just what's in the parentheses. And I'll show you why that's important here in a second. Okay? So if you divide off the 18,000, 18,342 divided by 18,000 is, what is that? 18,342?
1.019.
Okay, perfect. 1.019 equals 1 plus 0.25 R. Okay. All right. So now what do we do, Kev? This should look a little familiar.
Okay, then we would, well, I don't know. You gotta get the R or the numbers on one side.
Okay, so we got this 1 here. What do we do with this 1?
You would add it to, would we add it to the 0.25?
Nope, you can't because it's like
It's like
apples and oranges.
Yeah.
Yep, one has a variable, one doesn't. So you got this over on the left, right?
Yeah.
So we got our numbers here, we got this here. So we're gonna take this here to the other side.
Subtract it.
Yep, we're gonna subtract it, move it to the other side, just the opposite sign. So if we do that, this part goes to 0. Then we're left with 1.019 minus 1, which is equal to 0.019, equal to 0.25 R.
Then we need to subtract the 0.19 from both?
Nope.
No?
I think of it like this. Remember this, we were talking about. So we have this number here multiplied by a variable.
Yes.
All right. So we said when you want to split these up, because we want the number, the letter by itself,
Yeah.
we have to divide it off.
Okay, so divide by 0.25.
Yep. And if you divide by 0.25 here, you have to do it on the other side. So when you're done, you're left with R is equal to. Let me know if this is what you guys got. 0.076.
Yep.
And if we turn that into a percent, multiply by 100,
7.6%.
7.6%. Yep. So yeah, if you're presented with one of these problems, Kev, all you're going to do is come in and you're going to, it gives you something like this in parentheses. First of all, divide off whatever that number is on the exterior. So when you're done, you're left with what's just in the parentheses. and then now move all the numbers that don't have variables to one side. That's what we did here. So then now we're left with all numbers and then number of variables. And then add up whatever the variables are, then divide off that number, and that'll leave you just with that variable. Okay?
That makes sense.
You wanna do one more?
Sure.
Okay. All right. All right, Derek, what's 22 below it?
If the future value is 24,252 and the present value is 23,500 for a 6-month investment, what is the simple interest rate?
Okay. All right. So sometime at the end of the 6 months, I'll have 24,252. I currently have 23,500 at 6 months. What is my simple interest? Okay. So very similar to the previous problem. Now it's just going to be just changing the numbers. Okay. Up first, we'll look first is the time, 6 months. 6 months, 6 divided by 12.
1/2.
1/2, which is equal to 0.5. However you guys choose to use. All right. I'll come over here and we'll take our equation again. FV is equal to PV 1 times the quantity 1 plus RT. Or you may get a problem where it might give you the interest rate and you need the time. That was the only variable I can think of when they were changed. Like, hey, how long would it take for you to make $400,000 and get a $2 principal start? Okay? That would what they would want you to do. All right, so we'll go back and plug our numbers in. We get 24,252 equal to 23,500 times 1 plus R times T. So I'll put the T in front because I like numbers that way. R, I did it again. Dang it. See? Okay. All right. So we got it all set up now. So Kev, what's the first thing we do? Like we did the previous problem?
You're gonna divide by the principal.
Yep. So if we divide by 23,500. Yeah, I can see that. That's good. All right. So 24,252 divided by 23,500 is.
1.032.
Can I get an amen? All right. Trust you. You've been to Japan. I trust you. You have a passport. That's good. Well, you have to have a passport to be here. Oh, that was stupid. Okay. All right, which leaves us now 1 plus 0.5 R.
And we're gonna minus, subtract the 1.
Yep. So if I move the 1 to the other side, I'm left with 0.032 equal to 0.5 R.
Then it was divide by 0.5.
And when we do that, we have what?
0.064.
0.064, which is
6.4%.
a firm. All right.
Many high interest rates.
I know. This is like from the 80s.
Yeah.
Interest rates here.
Pay attention to these, Derek.
Yeah. You don't see interest rates on shit like this anymore. Okay. Any questions on just simple interest? Again, you're gonna have to, what is the interest or what is the future value? And none of you want to do this. If you saw this, we can run through it one more time, you'll see one more time how it works. And again, if it's T or whatever, the concept is still the same. You still do the exact same process. Okay? Any questions? Okay. Derek and I are sharing here tonight. This is good, I like that.
You printed out a whole book there?
I did.
Oh.
And then one night I saw Derek, this is like the very beginning of class, Derek's like, oh, a book. I was like, oh, here, take this, you don't have to worry about it. So, all right. So 6.2 now gets into compounded interest. Compounded, and yes, I think mortgages are not, I think they're compounded monthly, aren't they? I don't know. I'm trying to think what is not compounded.
Well, I think you're right, because I think cars are done daily, mortgages are done monthly, because if you're, the only reason why I think that is because I was told to pay off my mortgage faster if I wanted to do extra, wait till you do your original payment and then make another principal payment afterwards. And you might be right, it's monthly. I'm not sure.
Yeah, I know, I wanna Google that right now and see what it is actually.
Because I sold my house, I don't own it anymore. I'm not a homeowner at this point.
I can't wait to sell ours. Seriously, cannot wait. Compounded,
Yeah, I couldn't sell it fast enough to leave there and have a hurricane come through.
what types of loans compound monthly? I want loan calculators, I wanna know. Jeez. Alright, so yeah, compound interest. With simple interest, the interest rate is only applied once at the end of the time invested. Okay, there you go. Loan chart style. The most typical situation of compound when the interest is applied after a certain amount of time. That's when the interest grows for the rest of the time. For instance, most regular savings accounts have interest compounded daily. Kind of the same thing with a loan, meaning the interest is tacked on every day. After, a little bit of interest is in the account and also earns interest for the rest of the time the money is in the account, etc. In this case, we have a formula for the future value for compounded interest. In this case, it says future value is equal to the present, or the principal, times 1 plus R over N to the NT power. Okay? And so far we've gone over this stuff again. Future value is going to be your FV. P is your principal, or where you started with. R is your rate. And again, that's going to be in decimal. N is now your compounding period. There is a table right underneath that will tell you what N should be. And a guy this last summer who took the class, he was like so paranoid, like he went home and memorized that table. He's in Navy E7. Every time I see him, I still give him shit. All right, so it's compounded daily. N is going to be 365 monthly, quarterly, semi-annually, and if it's just annually. Okay, and then T is going to be again in years. So under N, I will put C chart, and T is in years. Okay, so someday when Derek owns his bank and makes billions of dollars, he'll be compounding every second. It'll just be a super, super low interest rate. Make sure you do the evil laugh. It works. All right. So we'll just jump right into the examples. First one says, $15,000 is invested for 6 years at 4.7 monthly. What is the future value? Okay, this is example 1. So it says the principal is $15,000. Invested at a rate of, what was that, Derek?
4.7.
Okay.
4.7.
Oh, thank you. Okay, so 4.7% is written as 0.047. Okay, T in this case is 5 years?
6 years.
6 years? Well, I'm batting like 0.25 tonight. And then N, it said compounded.
Month.
Okay, so,
That would be 12.
yep, will be 12. If I go to the chart, it tells me N will be 12. Okay, so we'll just go in and plug in some numbers. Okay, so in this case, take the equation, future value is equal to my principal, i.e. where I started at again, which is 15,000, what the loan shark gave me, times 1 plus R, which is 0.047, divided by 12. Yep. Close parentheses. And this is all to the power 12 times 6. So like we were talking last night with, or yeah, it was last night. We were talking about powers and logarithmic and everything like that. That's exactly what it is. Think of this as the base to that power. All right. So we'll start with the parentheses first. We'll get what's in the parentheses first. So 15,000 times 1 plus 0.047 divided by 12. What do you guys get from that?
19875.7. Oh wait, no, I'm thinking of.
Oh!
Yeah, just give the answer.
Yeah, okay, I know. I was like, oh gosh, did I not get that?
I got 0.00391667.
Give me 5 decimal places.
0.00391.
Is that what you got, Derek? Point.
Yes, that's good.
Okay. Yep, that's right. I'm gonna go one more, and I'll throw a 7 on that. That's a 6 rounded up. 3917. And that is 12 times 6. Do the math and the power real quick. So this is what you get when you're done. 15,000 times 1 times the quantity 1 plus 0.003917 to the 72nd power. All right. So if I add up what's in the parentheses, I get 15,000. Don't ask me why. I just did this on my calculator. I get 1.00397. So all I did on this step was add them together. Next step, I'm going to take that number and take it to the 72nd power. So now this number to the 72nd power. So if I take my calculator here and I type in that number first, I go 1.003917, and then on my calculator on your phone or yours as well, Derek, you can hit X, Y, and then hit 72. All right. When you do that, I got 1.32508.
Yeah, and many more numbers.
Yeah, many more numbers. I just stopped right there.
Yeah.
Because I want to save some dry erase. All right, now if I take that number times 15,000, I get what?
19,876.22.
Yeah, I got 2 more. We'll round that. Yep. Okay, so using the future value problems, what they're going to do is they're going to do one of 2 things. They're going to come in and they're going to say, hey, I want you to determine the future value, which we did. Ran through one of these. We can do another one if you guys want. Or they'll say, here's the future value. Tell me what the present value is. Okay, that's easy. That means we just have to take that and divide this, calculate this entire number, and then take this number, divide by this entire thing. Or it might come in and say, what's t, or what is n? Those. We'll do an example of that. Okay. The next one. Let's see. What is it? Okay, so the next one just says, yeah, this time I've got $50,000. So example 2 says I have a present value of 50,000. I'm going to skip writing all down here so we can just get straight to the bread and butter. 50,000 for 3.5 years. 3.5 years at how much interest?
6%.
6%. Okay. And it is compounded daily. Okay. Oh, yes. And then 6, how many years was that again, Derek? I'm sorry.
3.5.
Okay, perfect. Okay. So I skipped just writing down all the information, went straight to the bread and butter. Alright, so again, here's your principal times 1 plus the interest rate, 0.06. It's compounded daily, so I use 365, divided by 365. Close parentheses to the 365 times 3.5 power. Okay? Let's start with inside the parentheses. So I get 50,000. If I do everything inside of the parentheses, what do you guys get? 306 divided by 365. Plus
22.9?
Who to what?
22.9?
Negative, just inside the parentheses. So 0.06, try that again, 0.06 divided by 365.
Oh, I did something way off.
I know, that's what I was wondering, where'd you get 22 from?
Oh, shit.
And if you add 1, you get, I got
1.00016.
4.
Yeah.
Okay. Now the next step is I'll multiply the two numbers here for the power. 365 times 3.5. Ooh, that's a big number. I get 1277.5. Could you imagine doing this without a calculator?
That was bad.
I agree. Dear Lord. Alright, so the next step now is I'm going to take the 1.000164 to the 1277 power. So again, that all with your calculator, you'll do this. You'll take 1.000164 and then hit the XY button and then press 1277.5. That's what I got.
Yep.
Okay, perfect. 1.233, we'll go to 0.5. Yeah, if Miranda were here, I'd ask her where,
Actually, it's 6.5.
oh. 1.233,
6.5.
oh, I got 0.5. Let me try one more time. 1.000164, XY, 1.277.5. Yeah, I got 1.23305. That's what I got. What'd you get?
Well, I already
Oh,
got the next
okay.
one. Let's see, let's try this again. So. 0, 1, 6, 4, 3, 8. I got 6, 5. 1, 2, 3, 4, 6, 5.
Huh. Alright. Wait a minute.
Oh, yeah, it's because I did the whole number instead of just part of it, that's why.
Okay.
Yeah, I see.
Yeah, you guys use the whole number. I just use the partial number. That's why.
Ah,
Okay, that's fair. Either way, it's gonna get us in the same neighborhood. It should get us right. Yeah, 61,652.
I got 618. But same difference.
Yeah,
Close enough.
sounds good.
It's still a lot of money.
That's a lot of money. All right. Any questions on that? Okay.
There's some nasty interest rates.
Those are some nasty. Agreed. All right, take 5, get up, stretch your legs. We'll get something to drink here, and then we'll come back. And what I'll do is we'll do an example now where we have the future and the present, and wants you to find one of the variables over here in the parentheses. How do we calculate that?